All right, welcome to this extra little bit of lecture because our class got cut short. That's on heats of formation. Heats of formation is an extension of Hess's law. I'm going to go ahead and find here we go. So we're going to talk about heats of formation. Okay, and we defined this the other day in class right at the end when you guys were all ready to go and we were running out of time, so it was kind of quick. But heats of formation is the heat produced or absorbed. Okay, it's the heat produced or absorbed when a compound is formed from its elements. All right, and so what do I mean formed from its elements? Well, if we take a look at the various elemental forms that we are used to, so when we think about things, if I'm talking about a metal like aluminum, its elemental form is the solid. So that's an example of its elements. If we talk about chlorine, we're talking about chlorine 2 gas, because that's how we encounter it at kind of room temperature and standard pressure in nature. So chlorine gas. If we're talking about, let's see, mercury doesn't start with an M. We haven't done mercury, but mercury would be a liquid, right? And we won't do mercury, but I'm just trying to give you that's just that way you find that in nature. If we look down here, there are other things as well. So if we look at these tables, and this was why I didn't bring this to class. It's a gigantic table in the back of your book, and we need to look at all of it. But we can look at other things that are elements down here. So here, H plus. If we talk about H plus in solution, we consider that its element. So H2 gas would be thinking about H2 as that. And so that's going to fall out of the equations and how we use this. But this is super useful. We can use this to do Hess's law and essentially figure out what the enthalpy is for any reaction if we know the heats of formation. And the way we do that, we're going to go ahead and use this top equation as an example, but I'm going to rewrite it and I'm going to change barium to calcium because your book doesn't have barium ions in the back of the book. So what we have to do for these things is we have to write the net ionic equations for them. And so if I want to find the heat here, what I'm going to do, I'm going to rewrite it first just so it's 2HCl aqueous. Okay, and I can't look that up, but I can look its ions up. And then I'm going to make this calcium because that value is in the back of your book. And for this, it wasn't. For barium plus, it wasn't. And so then that's going to form us calcium chloride aqueous plus 2H2O liquid. Okay. So what we need to do with this then is we need to write our net ionic equation. So if there were no ions, it would be fine as is, but there are ions. And part of why we're going to do this is, well, let's do it because we're lazy and we don't want to have to look up as many things. And so this is going to become 2H plus aqueous, right? This is an ion, it breaks up, plus 2Cl aqueous, that's Cl minus, plus, so this, I'm going to correct myself here. Hydroxides are not solids. I was confused I let them fool me with this. Hydroxides aren't solids. It's not a solid. It can't happen that way. So it's going to be calcium hydroxide, solid, goes to make calcium. Calcium chloride is aqueous, so calcium 2 plus 2Cl minus aqueous plus 2H2O water liquid. Okay, so there we have our equation. This is our full ionic equation. To make it the net ionic equation, we're going to cancel out things that are common on each side, and that's these chloride ions, right? So now I've saved myself some trouble. I will not have to look up the heats of formation for those ions. Let's go ahead and look all these things up. So H plus, There it is. H plus is right here. It's right at the top. That is the element. So that one's easy. That's going to be, so we're going to have 2 times 0 for H plus. And that's going to be, these are numbers here that we don't have the units on these. If we had the top of the column, it would say enthalpy of formation. So change in enthalpy to form these. And that would be in kilojoules per mole. Okay, so I've got 2 of these, so it would be 2 times, well, 0 kilojoules. Let's just do kilojoules. Okay, plus, we don't have to do the chlorine because we cancel that out, or the chloride, I should say. But then we have calcium hydroxide. So does calcium hydroxide over here? Yes, it is. Here is calcium hydroxide right there. So that's going to be plus negative 985.2 kilojoules. That's there. Okay, those are our products. We're going to do the math part for this in a second, but I'm going to draw the arrow to show us that, oh, those are the reactants, to show that those were our reactants. And now we're going to do the products. So now we need to do calcium ion, and that's right here. Calcium ion formed from its elements, formed from solid calcium. This is how much energy. So we get a bunch of energy released when it forms the ion, and that's because this helps it become like a noble gas. And so there's one of those, so we just need to write the number down, 542.8. We don't have to worry about the chlorides, and then we have 2 waters. All right, where are our waters? Here's our waters. And those waters are liquid. That matters too, right? So we're looking at liquid water. This is the one for liquid water, and there are 2 of them. So we're going to go ahead, I'm going to put a plus there, but we're going to go 2 H2O liquid times negative 285.8 kilojoules. All right, so we have all the numbers we need now. Now, at the beginning of the semester, I did an example like the first third of the semester. I said, hey, in chemistry, it's almost always products minus reactants. And the example I hadn't looked at closely enough. This was when we were doing bond energies. It turned out that was one of our few exceptions. This, however, is not our exception. So what we do is we take, if we want to find the enthalpy of this reaction, what we're going to look at is we're going to take the sum of the enthalpies of formation of the products minus the enthalpies of formation of the reactants. Okay, so products minus reactants. So what that means is these are our products, these are our reactants, so I need to subtract the reactants from the products. So I can just take these green ones and just write them down. So I've got negative 542.8 kilojoules plus 2 times negative 285.8 kilojoules, okay? And then I need to subtract from that whatever the value is going to be for my reactants, which are 2 times 0, right? 2 times 0 kilojoules, which is going to be 0, right? And then plus minus, okay, or just minus, plus minus a minus, 985.2 kilojoules. Okay, we're running into the other side here, but I think we've got room. And so now I would just put this in my calculator. I want to point out that I've got a minus here. So this is like saying plus, this is like saying I've got plus minus 1 times everything in parentheses. So I can make this go away, and I can make that a plus, and I can make this a minus, but it doesn't matter because it's 0. That's going to be 0 in the end. And so now I'm pretty much ready to put this in my calculator. So if I get rid of my parentheses, this becomes 542.8 kilojoules plus, I'll go ahead and I'll just put these in my calculator as I'm going. So 2 times 285. Okay, and I get plus negative 5 71.6 kilojoules. I just took this bit here and multiplied that out, and then over here I took that minus and got rid of the minus, so now I've got plus 985.2 kilojoules. All right, and so now I just add those all up. So I've got 542.8, and I'll make it negative, and I'm going to take that plus negative 571.6, and then I'm going to take that plus 985.2. Okay, and what that's going to give me is, that gives me 129, negative 129.2 kilojoules. And what that is that's the enthalpy of reaction, right here, enthalpy of reaction. You can rewrite it, enthalpy of reaction for this reaction right here. All right, and we did that using those heats of formation, which are really handy because there's lots of them, and you can just look them up in the back of your book or any book, and answer that. So that's how to do that. Those problems will be, there's a couple of those problems in your homework. If you have any questions, please feel free to email me about those. Okay. All right. I hope you guys are having a good weekend. I hope you are you're surviving well, studying for finals. And if I don't see you before Friday, I hope all your finals before mine goes well, and I hope mine goes awesome. See you later. Bye-bye.